Welcome to a new test and teardown video. This time it's a Hewlett Packard HP 180. This is the mainframe, and this one is actually a renamed for military. Look at that one. Navy department. And the Navy version, there's a completely different name. And as you can see here, originally this was from USA, 115 voltage. And it's of course converted to Europe voltage. But it still is inside this chassis. I believe the original inner chassis is probably inside. I hope to see that. I don't have the front cover, but we can see here the locking system is here for the back. And I was lucky to get it with two different plugins. Maybe we should look a little bit on those. So this plugin is a rather normal dual channel oscilloscope and a timebase. So this is called the 1805 dual channel vertical amplifier with chop and alternating and all that kind of stuff. This one got a bandwidth of a 100 megahertz, so it's really fast for that time. And the timebase here is the 1821. It is a dual or delayed timebase system. And again, even those can be disconnected. We got a connector here in the middle, and this way you can combine or make whatever kind of timebase system together with different vertical input amplifiers. So this is a good way to design your own scope actually. The other plugin is very special. This is the 8755A, and it is a Swept Amplityde amplifier, and it's an analyzer that is used for RF systems like a forward enter return or a S1221, S11, all those kinds of things made with passive and active probes. And the idea is you of course connect these probes here, and then this system will amplify the signals from the probes and show the curves on the scope, of course. So we can select dBs, we can offset plus minus 59 dBs. We can move this and we can calibrate this and all sorts of fancy smancy things. So this one will of course contain all sorts of log amps and feedback systems. Like I said, I do not have the probes for this one. But I believe that depending on the frequency range, the different models of the probes, they could be either diode based or NTC based and all that kind of stuff. So it's probably low speed signals that is coming in and out here. I just expect to be able to experiment a little bit with this. I look forward to go a little bit deeper into this a little bit later. But first I want to see if I'm able to get any kind of pictures on the mainframe. So of course we need to open a lot more and do a deeper check out. Let's look a little bit here on the back, and again we got this military sticker here, and of course this is the serial number and all that. Got some different outputs, and we got a modulation axis input, and this is a typical American thing with the spare fuses and line fuses, and this is Also really nice that we have the voltage selector right here. And of course you need to replace the fuses if you put it into 230, because you need only half the amps. Let's see if we got... Come on, how difficult can that be? Normally it should be able to... No. No luck whatsoever. I just needed to pull a little bit harder. So, I got all the fuses in here. And all of them looks perfectly fine. So this is good. Now see if there's an easy way to remove this outer extra protective chassis. So now we're inside. It was surprisingly easy to pull from this cabinet. That made it, of course, a lot more rugged for military usage. Normally, we got only those thin little shield plates that's mounted in all these different holes and stuff. So it looks a lot different. And we got quite a big transformer in here, and a little bit of power supplies and transistors and all that kind of stuff. This looks a little bit like deflection amplifiers, if I'm not too mistaken. Let's look a little bit on the other side if we got some more of that. See, the power supply transistors, they will be from 1978. So that is probably pretty close to the age of this. We also got some other transistors here with thermal matching for DC stability. And this is a classic thing you'll see in old stuff like this. Look at this switch. The nickel plating here turns all white and dusty. So let's try and clean it a little bit and see if it's easy to see. It's easy to clean. With a little bit of alcohol. On this one here, it's like new on the outside, but still, it's still as bad on the inside. So this can create all sorts of problems. And this is something you need to be aware of. I already cleaned those switches here, so now they operate nice and smooth again. I was wrong about the transistors on this other board here. This is just, let's show again. There will just be some transistors for a power supply. It was not deflection at all. This, what you see here, is deflection. And it's quite easy to see. Here we got, and this is obviously horizontal deflection, because the vertical deflection goes via those wires here to this connector here on the side. And this is a classic way HP is doing this, to give you the super fast access to the to the vertical amplifiers in the plug-in module, because you can't have these super fast signals going all the way to this connector and then back again to the CRT. You want a direct, as short as possible, because this is going 100 megahertz. And here we got all the capacitors for the power supply and extra fuses sticking out of the side. So somebody put in some extra fuses. That is a little bit weird. It's always a good idea to double check the fuses in here. So what I realized is that we got this little plastic cover here, and it shows a little bit about the amps. So that'll be 12 volts and 15 volts and plus minus 100. And it looks, why did somebody scratch this off? How dumb is that? But anyway, it looks like those two should be 2 amps, and those two should be 0.375 amps or something like that. But one of the 2 amps fuses from here was actually mounted here, it's supposed to be this. So now I swapped everything and double checked everything is fine, and now we got the right fuses, the right places. Not that it matters much as long as the unit works, but if it's not working, I really would like the fuses to be the correct value. So we could probably limit the damage. So this is the high voltage supply, and we got another fuse hidden in here, so we need to go and have a look. We also got another fuse up here and another spare fuse. What do you know? And that will be, of course, the high voltage rectifiers and doublers. And see, this cable here goes to the anode of the CRT. Up here we got the beam finder. I think intensity, yeah, beam. So intensity is here, and this is the beam finder. And I believe the way it works is this disconnects the high voltage for the deflection amplifiers, also the one that is externally. So the high voltage for those amplifiers simply goes via this switch. And we got a little bit of a problem. So this is the focus potentiometer, and I really can't move it. I mean, the force that I need to apply here is so much, I'm afraid I will break something. So I will try and spray in some cleaning fluids. See if I can get this up and running a little bit better. And then I think we can power up. So I just wanted to have a little visual check here on the high voltage. Look how nice and clean that is. And this is of course the fuse for all this high voltage stuff, and that one is also intact. And the high voltage transformer, and the AC here goes to a voltage doubler, tripler, rectifier, something like that, and it goes via the red wire to the anode up here. The rest of the voltages here, the negative voltage, that will be cathodes and intensity and all that kind of stuff, and they're using all those capacitors here for those voltages. And I believe there will also be a feedback system, a little voltage set point, and some transistors here that's probably driving that one, of course, for the power. So I tried to clean this circuit board here a little bit, and it's still a little bit dirty here and there. See, I got those little white, I don't know if there's still some left here. It's not that easy to see, but it was full of white little, I don't really like the circuit boards not to be nice and clean. So yeah, we can also see a little bit of corrosion down here, but this is after my first little cleanup. I'm a little bit sad that I didn't take a few better pictures before the cleanup. So that is the focus potentiometer, and this one is of course at the very, very negative supply, and that is why it's using really thick cables for better isolation. And this extra little cap here, I removed this so I can put in some cleaning, and now it is possible to move it. See, a little extra plastic for more isolation distance. Even the potentiometer is mounted on a little plastic stand to create distance to all that, and a little extra plastic washer and all that. So they're really doing everything the right way. Also see how compact it is with all the different see, this is the switches and potentiometer in one, and I mean, it's just super compact, the whole unit. Just look a little bit on the oscilloscope plug in so we can see how fancy it is. I mean, this is really compact. Look how close all the switches and knobs. It's really difficult to get your fingers in here, and you can even see that. You need to really be careful. And everything got more than one function. You can clickety clickety and dial this and dial that and extra little switches and all that kind of stuff. And of course the time base and the, look at that. Clickety clackety doing this and that, right? So here is the deflection amplifier. This is directly to the deflection plate of the CRT, and that is the connector I showed in a previous clip that connects into the mainframe that goes directly to the CRT. And they really try to maximize everything. Look at the way that they're connecting to those transistors. This is a little bit out of the ordinary, isn't it? And again, no big surprise how crazy it is around the time base switch. This is a mega long switch with that many different features, doing a lot of different timing things. They've been nice to add a little bit of text up here that says this part is the delayed sweep and this is the main sweep, so you can easier figure out what is wrong or where is it located. Obviously everything here is of course transistor based, and we can see quite a lot of solder this and that. I mean, half of the transistors, they've been changed and resoldered. We got some diodes down there. Look at all the resolder this or that. I mean, and here is a nice little tunnel diode, and I believe we'll be able to find quite a lot more of those if I'm not mistaken. Only one. That is not right. So that will be the input channel 1 and channel 2. And look at the attenuators and all that. All the different switches that goes in here, you can compensate for everything. But again, this is a 100 megahertz oscilloscope. And of course you got some real special super fast amplifiers in here. Maybe we should try and open and have a look, because those will be custom ICs and balanced transistor couplings. We got some transistors here in sockets and some more balanced stuff. And here's a little little high-speed connector between the two different units. And up here in the this will of course be the sweep systems. We can see that we got again tunnel diodes and a lot of ooh, look what I found. Lead capacitor. That one we need to look at. So that was really good. It is that difficult to find. Maybe if that one is leaked, now we need to see if we can find any more of exactly this type anywhere else on the circuit boards. And there was one more little thing I wanted to show, and that was, look at the two more tunnel diodes here. So we got 4 tunnel diodes on this circuit board, and this one was replaced, and it's been soldered and desoldered. Some transistors been desoldered. Quite a lot of repair job. And here, this one is broken. See, this is supposed to be a connection to this one here. I believe this is an over voltage protection, so it's probably not super important for normal operation. And a little warm transistor here. So well, definitely interesting with this capacitor. Be able to remove this plate. You can see we got the 2 screws here. We also got some screws from below here between those 2 units. So the way to disconnect these two from each other, this is a little bit smart. So there's a switch or a little, you push here and you pull this. I'll do this with only one hand, but the idea is you push this up and then you can pull this out. You can also see this little locking mechanism. When this one is all the way up, then there's another little trick here at the back. Pull this one, and now you should be able to see what I'm saying? You should be able to pull those two units apart like that. Oh, let me put this here. So you can see those two. They lock here and here. And this one. And I think, no, this one is not doing anything to prevent this. Okay, good. Well, this is just how you lock this into the mainframe. So now I can open this unit and have a better look. And of course, I need to remember those two capacitors. I better put them so I can see what I'm doing right here. So now I replaced the two capacitors, and I've removed the little neon bulb with only one pin to it. And see, I found another one that looks very much like it. So this one is the old broken one, and the other one that I found, see, I even soldered a little bit on it. It's really, really close to the same size and all that. So here's a little trick. These contain neon in neon gas and vacuum and all that kind of stuff. And here's my little high voltage tester. And if they, see, if they shine exactly the same color and intensity, there's a big chance it's exactly the same gas mix. And that means also the same voltage, because those are actually voltage regulators. So I've removed the little shield here around those two custom HP chips, and so now we can just enjoy the view of these, and that'll be the two input attenuators together with the switch shields here. So the way that this works, there is a ceramic substrate, and I don't know if we can show this. You can probably see it here from the output end of it. The little white substrate contains all the different resistors for all the different attenuation steps, including the compensation capacitors. And the mechanical part, when you move this, we got some pistons actually that moves up and down, and they activates the different attenuators along the signal path. So here we go to a little field effect transistor in a socket, some more transistors, the amplifiers, and then I believe somewhere here with all those diodes and things we got the alternating and chop system, and then there's of course only one output. Maybe this is some trigger output or some other kind of stuff, right? Oh, we got another little funky component. What is that little thingy doing there? Well, that is a beautiful little thing, huh? The output from the amplifiers here, they go this way to the deflection amplifier. And here's another HP custom chip, I believe. And this drives the output transistors and this connector for the deflection system. And down here we got some other funky components. I don't know yet what is going on, but that is probably a little high voltage supply or another little local supply, because those plug-ins, there is an AC voltage that supplies all this. So when you need special voltages and they are not available, you need to make them. And that is what you can do with a little mains transformer like that. And here's of course a little local power supply. A little bit of, I mean, it's just really, really beautiful the way this is all made. And all this is done before CAD. I find it really, really, really impressive what they could do. 3D design like this, all the different design teams doing their little part of their job. Mechanical department, circuit board design, and all the wire harness guys. It's just, how could they make it so that it would fit together like that, with all the different holes and cuts and bits and pieces, and then again it clicks perfectly together with another module that goes here on top. Everything goes in here, the little bits and pieces, and it's just the connectors aligned like to the last of the micromillimeter. I mean, what kind of a world in 1970 something? Oh, this is impressive. So I feel lucky. Let's try and power this up for the first time and see what is going to happen. First, nothing happened. That is good. And then what did I do here? Everything is in the center. We got some display internal like that. Magnifier 1. Horizontal position. Everything here is in the middle. Yeah, maybe this is good. So let's try and see. Using 100 watts. And it will take a little while. Then we will see with the 100 watts. Oh, we got some auto, single. No. Oh, we got the beam. Oh, look at that. Here's beam finder. So we got a insane sharp display. I don't want to. Ooh. So that means deflation is way out of screen, and there's or something with that. So that is interesting. It seems to be alive with high voltage. That is good. Haha, look at that. I finally got a picture on it. It's not that easy to use this oscilloscope. We've got tons of things that can be done wrong about all these. Display this and display that and enable this and enable that. And I also believe that we got a few things that is not working. I'm trying to figure out exactly how to get the different channels on here, because alternating mode or chop. But you see, where is channel B? See, there is no position here. There's no line. There's nothing. And here is channel B. So it's obviously out of the screen or something like that. And here's, look at that. This is A position. Maybe this can't be right. That A is only supposed to be on the top. And here is B. Oh, and here is B. And this is also here on the top. So we got definitely some deflection issues and all that. See, chop or alternating. Weird stuff is going on. And that is variable. We got some offset here that is not doing anything. What else can we? See, here we go. Oh, we can actually give it a lot more. But that will not help us with the position. So this tells me there's definitely some voltages or some deflection systems or a lot of stuff that is not correct. We also got a little bit of a problem with the trigger. It is insanely sensitive, and this could of course explain why they've been soldering around in it so much. We also got these the display thing here, and then it goes. I don't know exactly why this is. So this is the magnifier here, and now it's looking really weird. So you can of course get into XY mode by using this input here, and then you select the external here. So now it's in scope mode, and then you go into external mode like this. So it's a little bit weird that it's kind of variable, but that's just the way that it works. We still got this really funny problem with the channel A here. See, if I go down below about center, then I have a clipping. So that means we, of course, need either a voltage or the deflection system is broken. But it's also a little bit funny if I add more gain like that. See, it's not helping me to get below center, is it? Yeah, okay, here I can overdrive it, and this creates, obviously, the negative voltage I don't have, and this way it helps my deflection. So this is a little bit interesting. I think I will go and look at the schematics and see if I can find a good explanation for this. So here is the regulated power supply. We've got 4 different voltages. We've got a negative 100, a positive 100, a positive 15, and a negative 12.6. So it's a little bit funny, and they are all perfectly fine. Otherwise, you can just adjust the different voltages here, and you can measure the 4 voltages here, and it was real easy to find the schematic and the overview of the power supply in the service manual. Also, if we zoom into the schematic, we'll see 2 different extra supplies for the filament of the gun, or the CRT, and then there is this flood gun variable. I really want to show that one. So here we got a nice picture on the oscilloscope, and what they're using this flood gun for is something really, really cool. Normally you got some bulbs and scale illumination. That will be some bulbs, but in this one we actually got, look at that, another little cathode gun. And the fun thing is it's actually moving the pictures. You're not supposed to do that. But that is just so cool. So now I want to look at and play with this Swept Amplityde Analyzer plug-in module, and let's see if we can get anything out of that one. But first, of course, I want to inspect how it's designed, and we see a lot of IC integrated circuits down there with a lot of pins, and I believe, of course, we got logarithmic amplifiers, and what is in there, we should definitely try and open that one. And another little plug-in board, and yeah, see, there's a connector down there, so we should be able to pull that one out. And why are we having this big room? And it looks like we got a little possibility to plug in something that is not here, and this part here also looks a little bit special. But yeah, the build is, as always with HP, just fantastic. Look at the BCD switches, how they connects with the circuit board. No fancy wires or anything, no, directly plugged into a connector like that. It's just maximum cool. And here at the bottom we can see all the high frequency connectors, and all that is, of course, exactly as I imagined they go. Oh, this is probably good, because this way we can see how everything is connected to the different connectors, and I should be able to add some signals and see what is going on here. So I took away this little top cover here so we could see it's, of course, full of the most fantastic modules, and I just let them loose a little bit here so we can see what is going on here. And this one looks a little bit brown, but this is, of course, super nice. Let's see. Oh, that will be HP numbers, called 1826 and then 0013. I don't know if that's easy to see. Well, we can of course go and look this up. A nice gold-plated circuit boards and everything. And of course, everything here is just analog, like it should be in the old days. So let's carefully plug this one back in and lift up this one. And here we see some of the more nice and cool modules. And this, again, is an HP I don't find any leak capacitors, so that is good. Yeah, all the other ICs, they also got HP numbers, and all those precision capacitors here, that is exactly for timing and precision. It's not because we have hundreds of volts. Those are, of course, high voltage, but they are film capacitors, so they're super, super accurate. This is definitely a nice circuit board. Yeah, no need to pull up the other two because they are completely identical. So I'll just put this back in here real careful. And the last one down here, what have we got here? Oh, we got that we got here. Let's look. 75 and 74, right? So that will be some flip-flops if I'm not mistaken, and that one is just another HP number. And sometimes you find, as you can see here, this is only the HP number, and the other one there contained HP number and the normal code that everybody could easily look up. But today we have all these conversion tables where we can look up everything, so it's not that difficult to repair it anyway. Yeah, beautiful. This gold plated on one side and normally coated on the other side. Can't really see this is, I mean, 55 years old or something like that. So now I really want to try and play with the 8755 plugin, and I just put the two inputs here for 0 offset, put them on, and let's just display B and A, and then we don't have, of course, any probes, but what will we see? That is the big question. And it is using only 60 watts. And is there a, see, we got a beam finder here. So it is all the way to the left. There is no sweep going on. So why is there not any? See, it is displaying two different nah. Nothing. It's a little bit funny, it's not showing anything, is it? That is super dead. But of course, without the probes, but I mean, it should definitely still sweep, shouldn't it? On this, on that. And then we have the beam finder here. Nah. Boring. Yeah. Oh, and here we go. B. Let's see. What happens if I move these? No. Plus, minus. It's just totally dead. That is just how bad it is. Well. I don't want to play anymore with this one today. As long as we got some beams on, we got the other one more or less up and running. I still got the deflection that is not perfect. So I still have a few more days to poke around with this one. Anyway, I also invite you to check out my HP 181 video. I will put some links in the description because I, of course, already published a video almost the same, but this is, of course, not exactly the same, but just another version, but it's still a little bit like this. So see you around. Bye bye.